Hello everyone, this is just another lecture on quadratic relations. We want to discuss one type of transformation that we haven't talked about it yet. So to begin with, as you see, I have already graphed y equals x squared, which is the basic parent quadratic relation. And I even have the table of values here as we have constructed in the past. So we have the vertex of the parabola opening upwards at the origin. Coordinates are 0, 0. Then we have these other points on the parabola, -2, 4, which is right here. And then we have -1, 1. And then we have 1 and 1. And the graph of this parabola passes through the point 2, 4 as well. So table of values is there. Y equals x squared is the basic parent function. Everything is fine. Now we want to investigate to see what's going to happen if we have a -2 inside the brackets. So instead of x squared, we have x minus 2 and then all squared. What's going to happen now? So to figure this out, I've already input the equation here, and we're going to see what is going to happen to this parabola. Maybe it's going to be shifting up, down, left, right, or maybe vertically stretched or reflected. We don't know what's going to happen. We're going to see shortly. Are you ready? Okay, let's go. All right, you see this new parabola here? The vertex is not at the origin anymore. The vertex is located at 2, 0. So initially the vertex was at 0, 0. Now it's at 2, 0. So what happened in your opinion? Well, we say that the graph of this quadratic relation, this parabola, is translated or shifted to the right by 2 units. And this is the name of the transformation. It's called a horizontal shift or horizontal translation. You can also say translation. So a horizontal shift to the right by 2 units, that's exactly what happened. So every single point we had before on the parabola have been translated to the right by 2 units. Look at this point. It was -2, 4, wasn't it? And now it has been horizontally shifted to the right to this other point whose x coordinate is 0 now because -2 was added with 2. So now we have a 0 because of this horizontal shift to the right. And the y coordinate, of course, it is still 4 because the graph didn't vertically shift up or down at all. So when we have x minus 2 inside the brackets, this is what is happening, a horizontal shift to the right by 2 units. Needless to say, if I put like 5 instead of 2, let me just change this to 5, for example, and see what happens. Oh, look at this. The parabola actually shifted horizontally to the right by 5 units. So I have this feeling that if I go like x minus 1, x minus 2, x minus 3, 4, 5, 6, 7, the graph is going to be horizontally shifting to the right by 1, 2, 3, 4, 5 units, as you saw here. And I wonder if it's like x plus 3, what's going to happen then? What is the graph of y equals x plus 3 squared look like? Well, if it's x plus 3, it's just like x minus 3 or x minus -3. Let's see what's going to happen. Oh, see what happened. The parabola, the blue one, is actually the same as the basic parent parabola, except that it's shifted horizontally to the left this time by 3 units. So the vertex is not at 0, 0 anymore. The vertex is at -3, 0. So we learned one thing, that if we have x minus some number, the parabola horizontally shifts to the right by the number of that number. Like if it's 5 units to the right, if it's 3 units to the right. And if you have x plus 3 inside the brackets, the graph is going to be shifted to the left by that number, in this case 3. So the blue graph is the same as the parent parabola, which is horizontally shifted to the left by 3 units this time. So generally speaking, instead of 5, 3, 2, all these numbers, we can have actually x minus h all squared. And that h represents just a number. It could be 2, it could be 1, it could be positive, it could be negative. And I want to see what's going to happen if, generally speaking, we have x minus h. And right now I have selected a slider here, h is equal to 0. So that's why if I just make these off right now, if I show you the basic parabola right now, this is like x minus 0 squared, which is the parent parabola, of course. Now I'm going to change the value of h shortly. I'm going to change it from 0 to 1, 2, 3, 4, 5, and you will see that this parabola will start, probably shifting to the right by 1, 2, 3 units, and so on and so forth. And then I'm going to try to change the value of h to negative numbers and see what happens to this parabola again. Are you ready? Okay, let's watch this. Okay, as you see, the graph horizontally shifts to the right and to the left, and the location of the vertex, as you see here, it keeps changing. So let me stop this at some point. For example, here. Okay, I stopped it. Look at the value of h. It's 2.5, right? So that means that the green parabola is translated, like it's the translation of the basic parabola horizontally 2.5 units to the right. So the transformation that we're going to write down in our homework question, on the test, on the quiz, whatever, we're going to say the graph is horizontally shifted to the right by 2.5 units. Now I'm going to let this go, and now we're going to see what happens now. Okay, so now I'm going to say the value of h is negative 1.5. So the equation would look like x minus 1.5. In other words, x plus 1.5 all squared. And you see that the graph is horizontally shifted to the left this time. And if you look at the vertex is at negative 1.5 comma 0 now. Okay, originally it was at 0, 0. So let's just enjoy watching this dancing parabola. It dances to the right, to the left, just like that, as you see. All right, so we got the idea here of horizontal shift. And now I want to just add a coefficient in front of x squared, which is something new. Of course, we had learned this about this in the past lectures. So what is going to happen if you have like 2x squared or 3x squared or 1/2 x squared? So let's try this other problem we had before, which was x minus 5. I'm going to add a 2 in front of it. Let's see what happens. So if I punch in a 2, you see that the graph is vertically stretched by a factor of 2, as we said in the past lectures. Even the original parabola, if I put like a 5, for example, in front of it, you see that the parabola is vertically stretched by a factor of 5, clearly. And if that is actually a negative 5, it's going to be vertically stretched by a factor of 5 again, but because of the negative sign in front, the parabola opens downwards, which means that it's reflected in the x-axis. Okay, so that's the role of that number in front of x squared. So I'm going to put this back. I'm going to put 1 back again, not to lose my original parent parabola, the basic parabola. And then here I'm going to add a value to the a in my generic equation. So I'm going to put an a here. Okay, and now I'm going to create another slider for a, and right now a is 1. So I'm going to change the value of a from negative 10 to positive 10, and we're going to see what's going to happen right now. Let me see. So the value of h, I haven't, set it up. Okay, so I'm going to put the value of h back at 0 so that we don't have any horizontal shift. And now we're going to see what is happening to this parabola when the value of a is changing. So now a is negative, so obviously the parabola opens downwards. Now it's positive, and it's actually positive 8.09. So the value of a is more than 1. We have a vertical stretch by a factor of 8.09, as you recall from the past lectures. And I'm going to let it go right now, and I'm going to try to stop it perhaps here at not 1.2, but something less than that. Yeah, here. So see here, the green parabola, you see that it has undergone vertical shrink or compression by a factor of 0.7. That's what has happened to the basic parabola. Because the value of a is less than 1, So we have a vertical shrink or compression by a factor of 0.7. Or if I make it even smaller, here it's by a factor of 0.2. Okay, and then the moment that the value of A becomes negative, of course, the graph starts reflecting in the x-axis. So let me play this and you can watch what is happening. So all sorts of stretches and compressions are happening right now. Parabola opens up and down as you see what's happening. So I'm going to stop this momentarily. All right, and now I'm gonna play the H. I'm going to change the value of H value. So right now that transformed the parabola is horizontally shifting to the left and right because the value of H is changing actually. And I'm going to make this A to change as well. So right now, two things are changing at the same time. So not only the stretch factor or compression factor, that A value is changing, not only the graph is vertically stretched or compressed by different factors of A, but also the value of H is changing, causing the parabola to horizontally shift to the left or to the right simultaneously. As you see, this is like a nice dance of parabolas here. Okay, so we're going to stop this whole thing and maybe I just go back to H equals maybe 2, and the value of A I can go to 0.5 maybe. All right, 0.5. Okay, so right now this green parabola is a parabola that has undergone two transformations. Number one, a horizontal compression by a vertical compression by a factor of 0.5, and a horizontal shift to the right by 2 units. These are the two transformations you have to write down. If somebody asks you what kind of transformation is involved with this parabola, that's what you're going to say. So the value of A is 0.5, the value of H is 2. So the equation will look like y equals 0.5, open brackets, x minus 2, close brackets, all squared. Okay, I hope you got an idea of what the roles of H and A are in transforming these kind of parabolas. Okay, thank you very much, and we will continue with another lecture later on. For now, stay safe. Bye bye.